Good morning, students. In this semester, we are going to learn mathematical physics. Mathematics is an important tool to learn physics thoroughly. In fact, mathematics is the queen of all subjects. So we are going to learn mathematical physics, under which we are going to cover these topics. The Unit 1 goes with the matrices. Unit 2 is vector calculus. Unit 3 falls on orthogonal curvilinear coordinates. Unit 4 belongs to Fourier series and Fourier transforms. And the last unit covers with applications of partial differential equations. So in this class we are going to deal with matrices. So matrices, under which these topics are going to be covered. Types of matrices. Today we are going to learn the types of matrices, especially symmetric, Hermitian, unitary and orthogonal matrices. And subsequent classes will be learning characteristic equation of a matrix, eigenvalues, eigenvectors of a matrix, Cayley-Hamilton theorem, inverse of matrix by Cayley-Hamilton theorem, similarity transformations, diagonalization of 2 by 2 real symmetric matrices. So these are the topics that we are going to cover under matrices. So we are going to start with types of matrices. So before that, we'll have to know what is a matrix. And of course, probably we would have learned in lower classes about a matrix. Matrix is just a square in which some elements can be existing. A matrix is a rectangular array or arrangement of entries or elements displaced in rows and columns put it within a square bracket. So we have a square bracket in which some elements will be there. Okay, some elements will be there. And we have rows and columns. So this is, for example, when you take a matrix and this is your row and this will be your column. So this is your row and this will be your column in a matrix. If a matrix A has m rows and n columns, m rows and n columns, then it is written as A equals Aij m by n. So the first one is known as row, the second one is known as column. M rows and n columns, they are all elements. Aij, they are all elements. Here I lies between 1 and m, j lies between 1 and n. So what is the definition for your matrix? The matrix is a set or group of numbers arranged in a square or rectangular array enclosed by brackets. So we have a bracket and numbers exist, and this is it exists only row. So we have 1 1 is a row, and here it is column matrix 1 2. It's a square matrix because equal number of rows and columns are there. Equal number of rows and columns. So 4 2 minus 3 0, and this is also an example of a matrix. A, B, C, D, E, F. Order of the matrix. If a matrix A has m rows and n columns, then the order or size of the matrix A is defined as m by n. For example, what is the order of the matrix? As I said earlier, and this stands for m and this stands for n. So m by n, it means we have 2 rows and a column. So this matrix, we have 2 rows. See, we have 2 rows and a single column. So m by n, the first one stands for row, the second one stands for column. So m by n. So this is an example of 2 by 1. This is the example of 1 by 2. So we have only single row. We have only one row, but there are 2 columns. So 1 by 2. And this is 2 by 3 matrix. So we have 2 rows and 3 columns. So 2 by 3 matrix. And of course, this is 3 by 3 matrix. It's a square matrix because equal numbers of columns and equal number of rows are there. So rows and columns are equal. So that's why we call this as a square matrix. And most probably in physics we'll be dealing only with the square matrix. Types of matrices that we are going to learn: row matrix, column matrix, zero matrix, non-zero matrix, square matrix, diagonal matrix. So these are the things that we are going to learn scalar matrix, what is a scalar matrix, what is a unit matrix, upper triangular matrix, lower triangular matrix, then triangular matrix we are going to learn. So first thing is row matrix. So row matrix in which we have only row elements will exist. So we have in a matrix we have only row elements. For example, a matrix having only one row is called a row matrix. A equals A 1j 1 by n is a row matrix of order 1 by n. For example, these are all examples of row matrix 4 7 2 9 3, and this is A B C D E. So they are all row matrix. Column matrix, we have only columns will exist. A matrix having only one column is called a column matrix. One column. A equals A I1 m by n is a column matrix of the order 1. So this is a column matrix. So there's a mistake here. So it's a column matrix. It is not a row matrix. It's a column matrix of order m by n. So A equals 1 2 in a column, single column. B equals 1 2 3 and C equals 1 2 3 4. Zero matrix. Zero matrix, in a matrix all the elements will be 0. So they are called a zero matrix. For example, you have matrix A equals Aij m by n is said to be zero matrix or null matrix or void matrix denoted by O, where Aij equal to O and I lies between 1 and m and j lies between 1 and m. So you look at all the elements, they are all 0 0 0. So 2 by 2 matrix, but all the elements are 0. What we call this as zero matrix. Non-zero matrix. A matrix A is said to be a non-zero matrix if at least one element, one of the entities A is non-zero. See, if for example, you just take this matrix, one element exists, all the other things are 0 0. So it's a non-zero matrix. This is also a non-zero matrix, and this is also a non-zero matrix. So examples for non-zero matrix. Square matrix. Rows and columns are equal. We call that matrix is nothing but a square matrix. If the number of rows and number of columns in a matrix are equal, then it is called as a square matrix. So A equals Aij m by n. If m must be equal to n. So A11. This is what we say. This is Aij. So this is I. This is j. So this is I. This is j. This is I. This is j. See, look at I is 1 1 1, which represents the rows. Column will be first column, second column, third column. So this is first row, correct? So this will be your second row. This is column will be first column, second column, third column. So A21, A22, A23, A31, A32, A33. So here number of rows are equal to number of columns. So they are square matrix. See, they are all square matrix. 3 by 3 matrix. Three elements are there. So three rows and 3 columns are so it is 3 by 3. It's a square matrix. So examples of square matrix will be 1 2 3 4 2 by 2 matrix. Again here it is 3 by 3 matrix, correct? You have 3 by 3 matrix. Square matrix is the principal diagonal. Principal diagonal means it represents the diagonal elements. So we have diagonal elements. So this is a diagonal, correct? This is your diagonal. So 5 7 1 is a diagonal element, principal diagonal elements. In a square matrix, A equals Aij n by n of order n, the elements A11, A22, A33. So this is A11, this is A12, this is A13. Here it is A11, A22, A33. So they are all called diagonal elements, main diagonal or leading diagonal elements. So in this example, 5 7 1 are principal diagonal elements. Okay. Diagonal matrix. If all the elements except the principal diagonal elements in a square matrix are 0. See, look at this matrix. All the other elements are 0 except the principal diagonal elements. See here 2, 3, 4. All the other elements, they are 0. So what we call this as diagonal matrix. So it's a diagonal matrix. See here, it's a diagonal matrix because all the other elements are 0 except the diagonal elements. So this matrix is called diagonal matrix. So if all the elements except the principal diagonal in a square matrix are 0, it is called a diagonal matrix. Thus a square matrix A equal to Aij is a diagonal matrix if Aij equals 0 when I is not equal to j. So here I is equal to j. Here also I equal to j. Here also I equal to j. See here, this is A11, I equal to j. This is A22, I equal to j. Is it clear? This is A33, I equal to j. Whereas these elements I is not equal to j. This is 1, 2. I is 1, j is 2. They are different. They are not the same. So it is 0. Else it is 0 if I equals 0, then main elements alone exist. Is a diagonal matrix of the order 3 by 3, which can also be denoted by a diagonal 2, 3, 4. So they are all, see, they are all diagonal elements. See, diagonal elements alone exist except all the other elements 0. So they are called a diagonal matrix. And what of this? All the elements 0. So your square 0 matrix is a diagonal. So square matrix 0 also is a diagonal matrix. Scalar matrix. All the diagonal elements are equal, then we call this matrix as a scalar matrix. See here, all the diagonal elements are equal. Minus 7, minus 7, minus 7. See, all the diagonal elements are equal. What we call this as scalar matrix. If all the elements in the diagonal of a matrix are equal, it is called a scalar matrix. Thus, a square matrix A equals Aij n by n is a scalar matrix if Aij equals 0 when I is not equal to j. See here, this is 0. When they are equal, and what and they also equal. See, minus 7, minus 7, minus 7. So this is A11, A22, A33. So all are equal. What we call this as scalar matrix. If they are not equal, then what we call this as diagonal matrix. See here, diagonal. They are not equal. Okay, it can be 7, 7, 7. It can be 1, 1, 1. Okay, so they are all scalar matrix. For example, you just take 5, 5, 5. See, 5, 5, 5. Here 12, 12. Here minus 7, minus 7, minus 7. And note that any square 0 matrix can be considered as a scalar matrix with a scalar 0. Unit matrix. So this is 1, 1, 1. So it's just now we studied about square matrix, scalar matrix, in which all the elements are equal. If the elements are 1, 1, 1, then we call this as unit matrix. If all the elements of a principal diagonal in a diagonal matrix are 1, we call this as a unit matrix. A unit matrix of order n is denoted by In. Thus, a square matrix is a unit matrix if A equals Aij n by n, I equals j, the answer is 1, I is not equal to j, answer is 0. So this is A11, A22, A33, all diagonal elements are equal 1, then another thing is 1. So they are called as unit matrix. So every unit matrix is a scalar matrix, of course. Triangular matrix. A square matrix which is either upper triangle. So this is we know that this is about a diagonal matrix, and this is upper triangular. This is lower triangle. See here, this one is upper triangle, and this one is lower triangle. A square matrix which is either upper triangular or lower triangular is called a triangular matrix. For example, you just take upper triangular 0, 0, 0. See here, upper triangle. This is lower triangle 0, 0, 0. See here. A square matrix that is both upper and lower triangle simultaneously will turn out to be a diagonal matrix, of course. So this is upper triangular matrix and lower triangular, together they are there, and we call this as a diagonal matrix, correct? Square matrix or a diagonal matrix, whatever may be. Now upper triangular matrix. A square matrix is said to be an upper triangular matrix if all the elements below the main diagonal are 0. See here, these elements are not there. Here alone we have elements. So what we call this as upper triangular matrix. See here, just take 3 by 3 matrix. You have 2 by 2 matrix. This is lower triangular matrix. Answer is 0. Whereas upper triangular matrix, some element exists. See, some element exists. So we call this as upper triangular matrix. Okay, this is your upper triangular matrix. Lower triangular matrix, in which see here some elements will exist in the lower triangular. Here see, just look at the difference between this and that. See, here you have 0 here. So we call this as upper triangular matrix. Whereas 0 is here, we call this as lower triangular matrix. Okay, so this is the example for 2 by 2, and this is for 3 by 3, and that for 4 by 4 matrix. Now we will have to identify what are the types of matrices. Okay, let us see. Okay, so what is this one? So upper elements exist in a matrix, upper triangle matrices, some elements exist. So this one is upper triangular matrix. Very good. This one, column matrix. Very good. This one, unit matrix. Very good. The last one, last one. Square matrix, of course, it's a square matrix. What a special one. Come on, you just see here. We studied diagonal elements, diagonal matrix. Then if both are equal, we call this as scalar matrix. They are equal, so it's a scalar matrix. This one. Here 2, 3, 4, they are different. So they are diagonal matrix. That's all. Now singular matrix. A matrix A is said to be a singular matrix if the determinant equal to 0. Otherwise we call this as non-singular matrix. If determinant equal to 0, we call this as singular matrix. If determinant is not equal to 0, non-singular matrix. Symmetric matrix, very important one, symmetric matrix. A square matrix A equals Aij is called a symmetric matrix. If Aij equals Aji, very important condition, Aij equals Aji. For example, you just take 1, 1. Okay, for I equals 1 and j equals 1. So A1. Interchange, the answer will be A11. Okay, just take A12. A12 is this one. Correct? This is A12. Interchange A21. What of A21? Again answer is the same. If they are equal, we call this as symmetric matrix. You just take this one. What is this one? What is the element? Order of the element A1, 3. First row, third column. Correct? So A1, 3. You just interchange. A31. What is the number A31? It's 3. So it's a symmetric matrix. A square matrix A equals Aij is called a symmetric matrix if Aij equals Aji. 1, 3 becomes 3, 1. 2, 3 becomes 3, 2. Okay, example is given. So for example, just take A12, answer is 2, which is equal to A21. A31, 3, which is equal to A1. A is symmetry. This is called A transpose. A to the power T is called a transpose. Transpose means row into column, column into rows. Okay, this is your column, column into rows. This is your row, row into column. So when you are going to interchange row into column or column into row, if the matrix are the same, then we can say that A transpose equal to A. You just interchange this matrix. A matrix is given by this. Now you are going to interchange rows into column, column into rows. You just interchange, answer will be the same, correct? Just see here 1, 2, 3. You just interchange again 1, 2, 3. 2, 4, 5. Interchange again 2, 4, 5. Interchange 3, 5, 2. The answer is 3, 5, 2. When you are going to interchange rows into column, column into rows, answer is the same. So it implies that A transpose equal to A. If it is so, then it must be a symmetric matrix. Okay. Now we will go for skew symmetric matrix. Sign. Look at the sign now. It is negative. See, it's negative. It is negative. This is also a negative. See, you leave this one diagonal. You are going to see this is 2. A1, 2. This is A2, 1. See, look at this minus sign. Whereas in the earlier case, it's the same. There is no change in sign. Whereas here there is change in sign. We call this as skew symmetry. So it's negative symmetry, but we'll name as skew symmetry. So it means that we are going to interchange A1, 2 becomes A2, 1 with a minus sign. Then we can say that this is skew symmetric. Okay, so A equals Aij is a skew symmetric if Aij equals minus Aji. So if it is so, you bring, for example, when you take, if it is so, for example, when you take J equals I equals J, then Aii equals minus Ai. You just bring this term to this side, you minus Ai, bring it to left hand side, that will give you plus 2Ai. Already one Ai is there. So Ai plus Ai will give you 2Ai, which is equal to 0. It implies that 2 cannot be equal to 0, so Ai will be equal to 0. It implies that Ai equal to 0 means A11, A22, A33 all will be equal to 0. So for all skew symmetric matrix, the diagonal elements will be 0. See, it's 2 by 2 matrix, you can interchange, there is a change in sign. So it's a skew symmetric matrix. A square matrix A is a skew symmetric matrix, A transpose equal to minus A. So this is the example of symmetric matrix and skew symmetric matrix. A transpose equal to A and A transpose equal to minus A. This is the example of skew matrix, and this is the example of skew symmetric matrix. So this is the example of symmetric matrix, example of skew symmetric matrix. Now transpose of a matrix. Just now we learnt about transpose of a matrix, which is nothing but rows into column, columns into rows. So you're going to change rows into column. A matrix obtained from a given matrix A by changing its rows into columns or column into rows is called the transpose of a matrix and denoted as A transpose equal to A. From the definition, it is obvious that if the order of A is m by n, the order of A transpose becomes n by n. Okay, this is if it is m by n, and this must be n by m. So it's a transpose of a matrix. For example, just take this matrix A. So we have 2 rows and 3 columns, correct? 2 rows and 3 columns, so 2 by 3. Now transpose this matrix, rows into column, column into rows. So this becomes A, D, B, E, C, F. So we have now 3 rows and 2 columns. So this is 3 by 2. Okay, so the order will change. M by n will become n by n, or n by m will become m by n.